Hey guys, this is lab 8, user frames. So what we're going to try to do in this laboratory is just quickly go through the process of defining a user frame. If you haven't reviewed the lecture on user frames, I recommend you do that first. So you can just pause this and go back and look at the user frame lecture video that I published under a separate title. So let's go ahead and get started here. We've already done one frame, right? We just did the tool frame. And I want to talk to you a little bit about the tool frames. When we were programming the tool frames, there were three different methods for programming tool frames. There's a 3-point, 6-point, and the direct entry. If you use the 3-point method, the 3-point method only identifies the location of the end of the tool center point. So this is our tool center point right there. So the default configuration, or the default XYZ for tool frame that's defined with the 3-point method is a little bit reversed from the world. So we're in joint right now. Let's move to world. And everyone knows how it works in world. So X is out, X positive is out, Y is to the left if you're looking at it from behind, and then of course Z is positive. Now if you define a tool frame with the 3-point method, and we can switch now over to tool frame, or to tool jog frame. There it is. Then let's make sure which tool frame we're in. We're in tool frame 5. So now we're in tool. So we're going to jog in tool frame now, and I want you to notice what happens. So the convention for the axis is a little bit different. So X positive is still in the same direction as world. But look what happens to Y. So Y is reversed. Y is reversed, and so is Z. So in the world of robotics, tool frame jogging is always towards the part, and that's why it defaults to that configuration. The Y is different, of course, because the triad has to be maintained, right? So if I flip the Z, if I take the triad out of my pocket and I hold it out in front of me and I keep the X in the same direction and I flip the Z, notice what happens to the Y. The Y reverses as well. So you cannot set the X and the Y in the same orientation as the world frame and just change Z, because your triad is always in place. So that triad, that relationship between X, Y, and Z positives is always the same. It's that triad. All right. So now let's move on to the task at hand today. Task at hand today is to set up a user frame. So we're going to set up a user frame. Notice when you go to frames, you go directly to the last frame setup, or the last window that you were operating in. So for us, that's going to be tool frame. So we need to get out of tool frame and we need to get into user frame. So we go down to other, select user frame, and now we're in user frame. Go ahead and use the first tool frame, first user frame. So we're going to select that first user frame. So we can arrow up and down using our arrow keys. We're going to select number 1 and enter. And go ahead and name yours, whatever you want to name it. You can put your name there. I think that's fine. And now we're ready to start recording, very much in the same way that we recorded points in our tool frame. We're going to do the same type of exercise in user frame. So our user frame is going to be, instead of the X being straight out, we're going to use this block in front of us, and we're going to use the right edge as our X. So this is going to be our X direction from now on, and this is going to be our Y direction. So it doesn't really matter so much which convention, because it's at a close to a 45. I can pick this as my X. It's just a matter of convention, however you decide. But for us, let's go ahead and agree that this is going to be our X direction. All right, so first step is to locate our origin point. And I'm pretty close to it now. I can see it's, if I just drop this down and I'm in tool frame, I don't want to get out of tool frame. I want to get into world. And I'm going to use it. All right, cool. All right, no worries. That's just Mr. King. Say hi. Hi, Mr. King. So we're going to drop down on the deck, approach our point. We can zoom in a little bit. So get a little bit closer. And that's pretty darn close. So I could play with it for 5 more minutes, but it's not going to make that much difference. All right, so if I do a shift and record, I've got my origin point defined, and now I just need to move in the X direction. So how do I move in the X direction? Well, I'm going to stay in world, and I'm just going to move up to this corner because I know, but I can move at any point in this corner. One thing you do have to remember is you can't just move it a fraction of an inch. You have to move it at least 250 millimeters. By the way, that's probably a test question as well. So when you're programming points in frames, the subsequent points must be 250 millimeters away from each other. All right, so let's go ahead and move this in X positive. So I'm going to move it up here to close to the corner, and then I'm going to move it towards the corner, and that's pretty close. We can zoom in, and again, we're not looking. By the way, when you're zoomed in, your axis of rotation is going to be around whatever you have selected. So my axis of rotation, if I want my axis of rotation to be around my tool, then I want to select that tool, and that makes it easier so I don't have to go in and out. So I'm pretty close here. I'm kind of splitting hairs now, trying to get this perfect, but we can move this just maybe a little smidgen more, probably overshoot it. There we go. That's a little bit off of the box, but that's close enough. All right, so that's going to be our X direction as we agreed. So shift and record. And now we're going to move to the Y direction. So let me zoom out, and I'm going to move now to the other side of the box to define my Y direction. And bring us in a little bit. So it's not exactly a 45 degree. I think we have this offset a little bit differently. So again, we select, again, if we select our tool in the tool in the attached to the robot, when we do this rotation, now it's going to rotate around that tool. So that's really convenient. So let's zoom in and see where we need to take this. Might need to take it just a tad more. There we go. That's fine. I like it. So we record, and we're done. That's it. That's a user frame established. So now if I want to move in the Y direction, well, first of all, I have to select it. So if I move to, if I select my user frame number 1 in my coordinate system. So now I want the shift key to be active now. So I go to coordinate and I arrow down to user. It's already 1. But if this was anything other than 1, I would enter a 1 right now. But it's already a 1, so I'll just get out of there by clicking on coordinate again. And then shift. And now I want to move in user mode. So this is a user jog mode. So if we did everything right, here's our test. We should be able to move in this along the X and Y and be able to pick points much more easily with this new frame of reference. So this is our X, this is our Y positive. So to move back to the origin, I'm guessing it's Y negative. I'm not guessing. It is Y negative. And it works. So looks like we did a pretty decent job of identifying the user frame. If you want to kind of test yourself on accuracy, get it close to that origin point, zoom in and see how close you are to it. That's pretty darn good. Mission accomplished. Good luck to you.